also a state thing, so that way a little more privacy with your student ID number. Good morning, ladies and gentlemen. How are we doing today? You can keep this. I need that. Is that done?
I think so.
Okay.
I
can't right now.
I know.
All right. All right, ladies and gentlemen, take out your periodic tables. Take out the worksheets that I have given you, all three of them. Take out your computer and get logged in, ladies and gentlemen. We have a bunch of things to do today. Tomorrow we will start preparing for your final exam. I will give you the lab activity. I will show you what you will do to start. But what we are doing now is what you're going to be doing on that lab activity. Okay? And then on the actual lab day, you will come in and you will actually perform the lab. You will go to 6 stations in the back of the room. There will be bottles of solutions there. You will test those bottles of solutions to try to identify what is in each of the bottles. Okay? And we will show you how to do that starting tomorrow. Today is the second to the last day for any late or missing work. Any retakes, I am not staying after school tomorrow, so you need to get them done today or before 3 o'clock tomorrow if you want to do them, ladies and gentlemen. Questions? All right, in your computers, I am going to take and put a Pear Deck for you. The Pear Deck is a review of what we have been talking about the last few days. So give me just a minute here and I will put it into your computers for you. All right, there you go, ladies and gentlemen. Let me now get attendance. All right, Keanu, Jaden, Andy, yep, Anthony, Ben, Anthony Baez. Maya's here. Jasmine is not. Michaela, Rose, Mason, Evan, Isaiah, Lucy, yes. Michaela, yes. Josh, yes. Morgan, yes. Dante, yes. Thank you, Morgan. I would have gotten it in a second. Hello, Jasmine. All right. All right. So again, ladies and gentlemen, for you as you're logging in today, they said that everything should have been resolved. All the password sync issues should have been resolved. When you go to log in, if you log in and it did not take your new password yesterday, you have to log in with Green Bay, capitalize the G, and the last 4 of your ID number twice. Then you need to go into ClassLink and do the same. When you log into ClassLink, it will prompt you to change your email. When you change your email from there on forward, then, ladies and gentlemen, it should be changed. If you have issues, you can go down and you could stop in the library and see them, and they will help you. Okay. All right. Is there anyone who did not get the Pear Deck that I sent out? It's not what I asked, but thank you. Anyone else? Michaela. Hold on. Open your backpack. Michaela, you're not showing up on mine, so you're going to have to do joinpd.com on a window on a tab on Google, and then there is the code you need. It's joinpd.com. Sorry. That is an L, and I would have the dot over it because that's a lowercase L. All right, ladies and gentlemen, so here we go. With your yellow sheet or your sheets, ladies and gentlemen, which of the following metals would have a reaction with CoCl2? So of these four metals, ladies and gentlemen, only one of them is going to have a reaction where it would actually replace cobalt in cobalt chloride. Which one of the four will actually replace cobalt in cobalt chloride? Drag your cursor to the top of it. You are looking on the side that says single replacement reaction, ladies and gentlemen. That is the side that you should be looking at right now. Find cobalt, find these three other elements, ladies and gentlemen. Only one of them should replace cobalt. Which one is it? So which one is it? What? Aluminum. Come on. Let's try that. Aluminum should have been the one. Aluminum is the only one that is higher up above cobalt. The other three are below it. Good. So which metal would have a reaction with barium nitrate? Which of these metals would be reactive enough to actually replace barium in barium nitrate, ladies and gentlemen? So far, we got 4 people who have responded. So which one would?
No.
None of them. None of them would. There isn't any of them that are more reactive than barium, ladies and gentlemen. Okay? All right. Which of these would replace iron in iron chlorate? The one that will replace iron in iron chlorate, ladies and gentlemen, is chromium. Chromium will replace iron in iron chlorate. By the way, in case you haven't noticed, the reason that a lot of things are with chlorate and nitrate is because they will not what with chlorate and nitrate? From yesterday. They will not precipitate with it. So it's an easy way to get an iron or a metal into a compound is to put it with chlorate or nitrate because they will not precipitate with it. All right, which of the following metals would react with barium iodide? This time there is one, ladies and gentlemen. Even though barium is very much near the top of that reactivity series, the one that is still above it, ladies and gentlemen, is potassium. Potassium and lithium would be above it. Okay? Questions? All right, ladies and gentlemen. So that takes care of that for us. Okay? All right. let's take a look at the double replacement reaction worksheet that we were doing the other day, ladies and gentlemen. So let's take a look at this real quick. Let's do the very last one, ladies and gentlemen. Let's do the very last one on this page. Okay. So here we go, ladies and gentlemen. This is a double replacement reaction. The first thing we need to do is write two good compounds. A compound for aqueous aluminum chromate and a compound for aqueous magnesium sulfide. So let's begin with aluminum chromate. Aluminum, Al, and it is a +3 charge. Chromate, CrO4. And according to the back of your periodic table, it is a -2 charge. So we are going to do the crisscross method and we will get Al2 CrO4 3. And that will be aqueous, ladies and gentlemen. The two compounds in the beginning of a double replacement reaction must be aqueous. If they were a solid, the reaction would have already happened and nothing will happen. Okay? So our second compound is aqueous magnesium sulfide. Magnesium is Mg. Sulfide, IDE ending, means that it comes from sulfur, a binary compound. Sulfur is an S. Magnesium is a +2. Sulfur is a -2. So our compound is MgS. And it is aqueous. AQ. Okay? So what are our metals here, ladies and gentlemen? Magnesium and aluminum. So these are going to switch spots on the other side, ladies and gentlemen. And again, I don't care which compound you write first. It absolutely does not matter. But one of our compounds is now going to have Mg, which is a +2, with chromate, CrO4, which is a -2. By the way, this 2 and this 2, when we brought them down, they would have ended up canceling out. That's how I ended up with MgS here. In case you were wondering what happened to the 2's. If I brought them down, I would have to reduce them. Same thing is going to happen here. If I bring these 2's down, I'm just going to have to reduce them anyway. So this compound is MgCrO4. That is one of the compounds. Now my second compound is aluminum, which is still a +3, with sulfur, which is still a -2. Because of that, crisscross method says Al2S3. Now you'll notice I haven't written down any states by these yet because I have to go through and check them. If everything were to stay aqueous, ladies and gentlemen, if everything were to stay aqueous, this reaction would not occur. You'd write no reaction underneath it and you would be done. But you need to at least write these compounds to be able to see if they actually occur. So when you look on the front side of this sheet now where it says double replacement, find chromate, CrO4. It is in the middle section at the bottom, ladies and gentlemen. CrO4 is in the middle section at the bottom. That section is normally aqueous, but there are some exceptions that would make it a solid. For chromate, the exceptions are silver, lead, barium, strontium, and calcium. Is chromate with any of those? So then this, ladies and gentlemen, this stays aqueous. Now we go to the aluminum sulfide. Okay? Now sulfur normally precipitates. It is normally a solid with most things. There are some exceptions. Ammonium, which it is not with, NH4. And also, aluminum is not a cation in group 1 or 2 of the periodic table. Please remember, group 1 and 2 of the periodic table are right here. These 12 elements. And aluminum is not in there. So therefore, it is not with an exception that would make it be aqueous. Therefore, aluminum sulfide is our solid here, ladies and gentlemen. So this reaction actually occurs. Yes, Michaela.
What does aqueous mean?
Aqueous means dissolved in water. Okay? Aqueous means it will dissolve in water. It will go in there and it will basically disappear, if you will. So you remember when we put the copper chloride into water and it turned blue? There was still some powder on the bottom, but the rest of it did dissolve. That's what it means. It's like putting salt or sugar into water. Those are aqueous. They will dissolve in water and it will go away, basically. Now, it's still in there, but it's dissolved. It's broken apart and spread out evenly. Okay? If it's something is a solid, that means it won't dissolve in water. It will go to the bottom of the container and it'll sit in the bottom of the container. Or maybe it'll float on the top, depending on how dense the precipitate is. Okay? But you will definitely be able to distinguish these things. Okay? And we will show you that tomorrow when we do a practice of our lab. Okay? When you get two things that precipitate, you will see a very clear change when you mix these two things together that indicates, okay, something happened here. Okay? So you're just going to have to hang on a little bit and trust me on that one. Okay? All right? So, ladies and gentlemen, now that we have that done, now we are going to take and balance our equation. Al, Mg, S. Now I'm going to show you another little trick you can do here. If this trick confuses you, please feel free not to use it. I'm going to leave the CrO4 together here. Why? Well, it's CrO4 over here, and it's CrO4 over here. So I'm going to leave it together as a group when I count it up. So there are two aluminums here. There's one magnesium here. There is one sulfur here. And how many of these CrO4 groups are here? So I'm going to treat them as a group, just like they were a single ion. On the other side, I have one magnesium. How many of the CrO4 groups do I have over here? I have one. How many aluminums do I have over here? Two. And how many sulfurs do I have? Three. Okay, so I need to balance the sulfur and I need to balance the chromate. Which one do you want to start with? There's only two. Pick one. All right, let's do sulfur first. Which side needs more? The left, the reactant side. So in front of the compound with sulfur over here. Now you've seen or you've heard me say this a bunch of times if I've come up to you and talked to you individually. How many sulfurs here? One. So what number times 1 will give me the 3 that I need? That's how I determine what number I'm putting in front. I have to put a 3 in front here, ladies and gentlemen. That is the only way I will get to 3 sulfur. But what else did I change? And there's nothing I can do about that. It was balanced. There's nothing I can do about it. I had to unbalance it. So now I need to balance magnesium and chromate. Again, you could pick either one. They're together over here, so this is going to work out. So let's do magnesium just because it's up at the top. What number in front times 1 magnesium will give me the 3 that I need? 3. Now, what does that do to the chromate? Makes it 3 as well. Makes it 3 as well. Okay? So I normally don't do this with polyatomics. Leave them together. But in this case, because there's only this one polyatomic here, and it is exactly the same on the other side, it's CrO4, I chose to leave it together. If I had split these up, it would have still worked out. Okay? And I don't normally like to do this if there's 2 polyatomics involved, because it just gets too confusing some of the time. Besides, if there's two polyatomics involved, we can ignore oxygen because oxygen is probably going to be in both. Questions? Yes, no, maybe so. All right. Do you want me to do another one? Do you want time to work on things? Okay. The hour is yours, ladies and gentlemen. If you have questions, if you need help on something, I will be happy to come around and give you assistance. I will be happy to check over what you're doing, but please remember, the answer keys are also online. Now, someone did point out to me, and I can't remember who it was, but somebody I think in this class yesterday or in one of my classes pointed out that one of my answer keys had a wrong answer on it. I think I flip-flopped the compounds on it or something. If you run into a case like that, please let me know. I will try to go back and correct them. But normally I'm sitting at home doing this, and sometimes my brain goes to heck to, and I mess up on an answer key. Please let me know, and I will correct it. But don't come in and go, well, I can't trust your answer keys. They're all terrible. Okay, well, maybe they are. Don't trust them, then do it on your own. But if you run into one that doesn't match what you're doing, maybe it is an error in my answer key. If you run into everyone that doesn't match, probably what you're doing then. Okay? All right, ladies and gentlemen, go to work. Go to work, go to work, go to work.